Hi, my name is Carson Lang. I'm the Technical Regional Manager at OptaSense, and today I'm here to demo the splicing, the use of the ODH or the DAS unit, and the OTDRing. So hopefully I can give everybody a practical tutorial that you guys can use to hit the ground running with your systems and set up in the field on your own. It's a little different here, but what we've done is we've just created our own box to house the OTDR in so that we can transport it and take it to the field, and we don't have to touch the unit and it just sits there as is. But this item here itself is the OTDR, and this is what will be used to analyze the fiber. Important components here. On the top end, you'll have a USB and a power connection to charge and or to take off the traces that you collect. So there's a USB connector. There's also two optical connections on the top. One is for the multi-mode fiber and the second is for the single mode fiber. So what we've done, the reason why this looks different too, is underneath this plate we have a 500 meter fiber optic buffer cable. The reason why we do this is that it helps us fault find any kind of reflections or maybe a bad splice where it's broken. So it's kind of a reference. So we know there's 500 meters that sits right behind our OTDR, and if there is a reflection, then we know if it's past the 500, we know it's either at the wellhead or your optical connector at your patch panel or somewhere else. And it also helps you know that your connection is clean too, because when you're sitting right at, say you plug directly into your OTDR and you have a reflection, you don't know if it's your OTDR that's dirty and you need to clean it, or if it's actually the connector. So it helps in troubleshooting whether you got to clean your connectors or redo the splices. So again, it's also, there's a lot of features to these things. It can do quite a few things, but it's pretty basic. And I'll just show you guys what we use and what you can use to analyze your fiber when you get to the field and the splices that you've done. When it turns on here, you'll have your different menus and options you can go into. On your right hand side, there will be different menus to go into, but right off the start you'll see that there is a selection. It asks whether you're going to look at a single mode or multi-mode fiber, and when you hit it, you'll just see down here in the menu it flips between the two, and you just select the fiber that you'll be analyzing. So in this case we're doing single mode, so you would select it. And like I said, there's several options or features in here that you can use, but what you would want is just the OTDR standard option on the top, and then you hit enter and it will take you right into begin analyzing. Like I said, there's different modes on the side, or options, sorry, but the ones that are probably most important to get going right away are setting the length of the fiber that you're going to be looking at or analyzing, and then the pulse width. So here, when you go into the menu option for setting your distance, there's just preset distances of 500, 2500 or 25,000 meters, and just select the one that's in range of whatever. If you go over, it's perfectly fine, but select the range of what's suitable for your fiber. And you can just go through the options just by turning the dial or moving with the arrow keys. So this one I think is 5,000, but we'll do 10,000 meters just to capture it all, to make sure. there is a pulse width you can select to use to interrogate the fiber. So the smaller the pulse width, the finer detail you'll see along the fiber optic cable. The larger the pulse width, it's just going to quickly scan through, and you won't catch as many of the losses or issues with the cable. So we picked the smallest one available. The further length you go, you're going to have less options with pulse width. It's going to keep getting larger so that it can send that light pulse down the fiber. So in this case, I'm going to pick 10,000 meters. I'm just going to come over and pick the 20 nanosecond pulse width. There's another option that you will be able to pick as well, is the averaging time that it's going to collect the trace over. Again, the averaging gives you better resolution on the analysis of the cable. So what we do is we pick 1 minute, that's good enough. If you just want a quick trace to see what's going on, you can go down to 15 seconds and it'll just quickly analyze just to see if there is a break. But the settings we go with are just kind of standard for our clients in the industry, is just 1 minute averaging. Be more accurate with your trace, you can set the index of refraction of what the fiber is, but it's not necessary to do. On single mode, you have the option of 1550 and 1310 nanometers as the wavelength. And what we do for our system is we want to try to replicate as close as to the system as is. What is the system going to see? So in our case, we collect 1550. You can collect both of them at the same time. It's just going to be longer trace length. But 1550 is good, and then it will be representative of what the IEU or the interrogator will see. You want to try to keep this E2000 as clean as possible, and the face of it. So before you plug it into your OTDR or into the IU, you want to clean it or wipe it down. So what we do for best practice is you can use your fingers to kind of pull back the lid, but it's kind of awkward, and they come off pretty easily. So there's a little tool that you can put on, and it will hold it for you so it's not so awkward. And you just place it on and it will hold back that lid, and now it exposes the face of the connection. And then what we do is to get rid of the dust. You don't want to wipe it because the face will scratch very easily, and any kind of scratches that go across, they'll actually cause reflections right at your connector of your unit. So that's why you want to try to practice proper cleaning techniques and keep these things as clean as you can, and try not to drop it or scrape it. But what we do is, once it's open, I just dab it, and don't pull it or move it, just dab it just to kind of get it a little bit wet if there is any dust on there. And this is called a clee top, and what it is as well is it just has a spool of fabric in there that doesn't have any kind of fibers on it itself, so it's not going to scratch or add dust to your optical connection. All you do is you open it up, then you just put it on there and just slowly pull the face of the optical connection across to clean it, and you're good to go. There is another option to clean as well. It's actually a pen. It works just as good. Same thing. It's just a piece of string that's spooled up inside, and when you click it, it just moves past and wipes off the dust on the connector. It has an adapter on the top, and what it allows you to do is you just put this little holder on there, pop off the top, and then you can place that on there. You just click it, and the string will move past and clean the face of the optical connection. So those are two ways you can use to clean it. Some guys and operators, they prefer this pen. I use this one, but it doesn't matter really. And we've selected the type of fiber at the beginning of what we wanted to analyze. We'll just plug it in to this connection. Let's bring it back up here again. So once it's connected to your OTDR, we'll just select again. I've set up my settings. Then I just say manual test. And you'll see that it will start shining a pulse of light down, and the trace will automatically appear on the screen, and you can see it's collecting the length of it. Zoom in and out, and then you can just move the dial to move along to see certain areas. It's going to be kind of hard for you guys to see, but I can show you after. The two important things we look for are reflections, and you'll see them as large spikes on your trace. So sometimes you can get rid of that by fixing the end of your spool in this case, or you may have access to the fiber if it's laid out on surface and you can go and fix the end. If it's in a well bore scenario or the end of the fiber is in an area that you cannot get at, our systems actually have a way of ignoring that high reflection. And the reason why you want to get rid of that reflection is that with the optical components in the systems, they're very sensitive that this amount of light coming back to the detector over time will actually wreck the optical detector in the unit. So you want to try to fix the end reflection if you can. If you can't, there is a setting in there. I can show you guys how we set it up, and it ignores that light and protects the optical device in there. You might have a reflection at the front, and same thing again. You want to probably redo your splice or clean the optical connection. So a loss will just look like a drop in the signal. You'll see it, it's very apparent. For our systems, kind of theoretical rule of thumb is 6 dB loss, and then you start getting into issues with your signal. You may see losses either at the connector, and they have specific ratings as well, so those are usually fine. This loss is going to be from this connector. And sometimes you'll see either a loss in different index of refractions of the fibers going together, but they won't be significant enough to affect the signal that you're collecting. The trace, it will report back the total loss across the fiber as well. You can operate higher than 6 dB loss in total, but you'll notice that the data quality will start to lessen. And usually you can't do anything about it, but if you guys have the fiber on surface, you shouldn't have issues with that. There is an option that when you run the trace, you can have it autosave. If that is not on, it's pretty easy as well. So once my trace is complete, you can just hit save. The menu comes up and it will do an auto, it'll have a name specified either by date or the wavelength used. You can easily edit it by selecting it, and a menu pops up and you can rename it to what you would like. Or you can leave it on the system, pull it off by USB and rename it easily. So this is the unit you guys now own. There's two pieces to this. The top part here, this is the interrogator unit itself. This is the DAS unit, which will be doing all the data or fiber optic analysis. Down here is just the basic computer. This is what's going to run the software and do some of the processing, back-end processing before it stores it to the drives. These components here are just SATA drives that you can add in yourself for storage, portable storage. These ones are empty. There's some 12 terabytes in there already. Again, it's just a really powerful computer, so there's nothing really special about it other than the amount of RAM and everything in there. This piece here is a KVM, keyboard video monitor, so it's really nice to have it all in one place. You don't have to have extra equipment. A little latch below just moves it so it comes out, and then you have that component all together, one piece, monitor and keyboard. So a trick with this here is that there's an extra lock on the side, or sorry, a release lock. You just pull, it's a black tab, you'll see, you just pull it towards yourself, and then it allows it to slide in and sit inside. This piece here is, we call it an SIU. But what it is this is the GPS component is housed inside. So there's two GPSs in here just for redundancy. And this is what's going to lock and sync the data to GPS. It also has some seismic components to it as well, where you can have a trigger in that will actually trigger the system. And it also has a trigger out, so you could feed out a time break if needed. But usually what we use it for is to collect a time break. The software is set up that once it's running, a time break comes in, it will just auto-record any kind of trigger on the system, regardless of what it is. I'll show you on the back later, but there is another connection to this that also sets the voltage level of the trigger if you are receiving one and want to record it, so that you're not triggering off lower voltages that might be around. Fan, a cooling fan, this can be removed, but just leave all the pieces together as is. You can take it out, everything will stay together. On the back, you'll see this green connection. This is that optical connection, just like on the OTDR that I showed you. This is where the E2000 will go in, and this is where the laser comes out. There's a laser key on the back side. There's also a laser key on the front, and this is just for laser safety, that it requires redundancy in the systems for the type of laser that's in there. You won't have to remove the connections, but again, part of the laser safety and redundancy is a laser lock key. You never have to remove this, but if some reason this is missing, the laser will not turn on at all. It will not engage. So just always leave this plugged in. We never remove them, but it's required to be there for, like I said, the type of laser that's in there. These are LEMO cables. Again, if you do remove these type of connections here, I'll show you what they are, but there is a red dot on the top to show you how it inserts and goes in. We have these ones color-coded, but they are also keyed on the side. There will be a specific key that you cannot plug it into the wrong plug-in by accident. It will only fit into a specific one. So on the top you'll see there's a little indent, and that matches up with the different connectors. The most important one that you'll be using is this black one, which is the GPS sync. So this black cable would just plug into the SIU on the back end here, and it's labeled as GPS. This is the one you'd use the most. This brown one is just the control, and like I mentioned before, if there are incoming time breaks to set the voltage, this just talks to the unit. It just allows the control for the voltages and that. So it doesn't need to be in, but again, this one will go to a connection on here that's called GPIU. And this is just the control device. The other one, this blue one, is a trigger. So What it does is it triggers the unit and everything to record. So if a time break comes into this SIU device, again, this is just the control specifically for any kind of time break. You guys probably will not be using these. In our seismic operations, we've kind of moved away from receiving time breaks. And what we do is we just receive the time break file from the source, and you can go through and chop out the data later. So all we do is we just record live and then go back in with a time break file and parse out the data as required. It makes it a lot easier for operations. You don't have to worry about timing and all that between the units. It does not hurt the device to leave this on and have power come back on and off. You can turn them off, but we leave it on. You'll also have there are Ethernet connections up here as well. There's 4 of them. The 3 are just used for special cases in troubleshooting from our optical team and the guys who make the device. You won't need them. There are special cases where certain data types you can also have coming out streaming at the same time. But for what you guys will be doing, and a lot of what we do now, is we just use the one connection for that data type. Ethernet will come down and connect to your PC. Everything's set up as is. All the IPs are ready to go. But down here we do have it labeled for the Ethernet port. Does not have to be specific to this one, but everything's set up and ready to go. And if you're familiar with IPs and setting it up, you could change this. But we'll just plug this one directly into the one labeled IU. So now it's connected to the PC. Here, or actually, sorry, this SIU, like I said, is the GPS controller, which is going to sync to GPS. On the right-hand side, it's labeled GPS 1 and 2. Again, these are just redundancy for the field. You don't need it, but they're a D-type connection. So this end of your GPS antenna can just plug directly into here. You just screw it on. Really have to control. I'll show you in the software where you can activate GPS, but other than that, this is just the passive unit that once PPS is coming in and it sees a satellite, it's just going to do its thing. And you'll just tell the software to sync when needed. We have the different connections already connected. So for internet, if you do have an internet connection that you are going to remote monitor into the system, all you need to do, which we'll do today as well, is just plug directly into one of these ports and everything's set up automatically that this system your PC will see internet. Here is an ECPS just below the bridge. And what this is used for is for remote monitoring. So you'll see all the power. It's a power bar that you can control remotely. So you'll see all the devices are plugged into these ports. There's a software on the computer that allows you to access this. And again, for remote monitoring, if you need to reset or troubleshoot the system, you can log in and tell it which port to power cycle. Again, the software will allow you to designate the ports for whatever you want. We've already have them labeled so you know which is the PC and the IU. So you'll never have to touch this. And this power bar, you only need a single connection. So the power that we have here, you would just plug in and everything is going to power on and you don't have to worry about touching any of this. Yeah, that's it. You just have your standard USB 3s, different monitor ports as well. If you want multiple monitors, we'll connect one up here so we can see the software easier. Good stabilization in here. We ship these offshore and, like I said, all around the world, and these, we never take them out of here. The IU will be safe sitting in there.